Good morning, fellow programmers. Thanks for joining me. I'm T-Pain, and welcome to Let's Learn C++. Feel free to use the skip ahead feature on the right hand side to jump to any specific sections or examples. Today we'll be using Visual Studio Community Edition, which you can download from visualstudio.com. However, you can follow along with whichever editor or IDE you choose. Make sure to have annotations turned on so you can see any updates I make to these videos. Today's focus will be on operators and inputs, which builds heavily on the previous two lessons, so check out those if you are unfamiliar with a topic. If this is your first programming language, I'd strongly recommend checking out my Let's Learn Python series, which teaches you the fundamentals of programming. All you need are the Basics and Object-Oriented Programming series, linked to the right, and you'll be well prepared for this C++ series. Alright, input! How do we do it? cin is the main function that we're going to be using for getting input into C++. Cin is short for cinnamon, one of two common ways to get input by the user, and it's followed by a greater than sign, and a variable to store the input. By the way, it's not really short for cinnamon, that was a joke. It's just cin, short for C input maybe. The double greater than is called the extraction operator used to pull something out of the stream. And it's the opposite of the insertion operator, which we've been using for cout. Does it matter that you know these names? No. Alright, so let's get coding. So here we have our default code of include IOStream right at the top. Then we're using namespace standard. And then following that we have the int main function without any arguments. And then that block of code just contains the return 0 line. And that's it. So on this first line within the main function, we're going to type int x semicolon just to declare a variable. Then we're going to type cout less than, and then we're going to type with double quotes, please enter an int colon space. Okay, so there you can see that, and we're going to end that, of course, with a semicolon. We're not going to end it with endl, and you'll understand why here in just a minute. Then we're going to type cin greater than x semicolon. After that, we're going to type cout less than, and then double quotes, type thank you with an exclamation point because we're thanking the person, double less than sign, and endl semicolon. Oh, and I'm going to go ahead and collapse this Solution Explorer on the right hand side just so that we can see our code more easily. We won't be needing any of these windows. We can always open them back up if we so desire. So now you can see my code more cleanly. Alright, let's go ahead and save our file and run the local Windows debugger. Now it creates this prompt window that says please enter an int, and we're just going to enter 2. Enter, and it says thank you, and then it closes out the program. If we create another cin afterwards, it'll actually stop the program from closing out. This is important because we're going to be using something similar to this from here on out so that we don't actually have to enter debug mode in order to stop our program from closing out. Save it, rerun. Alright, and output this window. Please enter an int. We can enter 5. It says thank you, and then it has the cursor waiting for another enter key. And if you press enter, it won't actually stop. So you have to enter a number. And then we'll just press 2 and enter it out. So this code works pretty well. So we have x to store our variable, and we have cin to pass in the user's input and store it in x, which is very cool. There are a few problems, however. Firstly, it cannot handle spaces very well. Second, enter does nothing. It merely steps us down the window. Next, it errors out if an int is not entered. So let's walk through some of these problems. Let's go ahead and rerun it real quick. Here's our window. So the first problem is it cannot handle spaces very well. Watch what happens if I type 1 space 1 and then type enter. It immediately exits out the program. The reason being is because the space is interpreted as the enter key, and it just passes it in to the next time that we call cin. So 1 is passed in here, and then the second one was passed in here. So that could be a problem if you're entering in multiple values. Nextly, the next problem is if you press enter. So when we type 5, we press enter, it says thank you, and we could type enter a number of times, and all it does is just move our cursor further and further down the window. So we'd have to enter another number in order for it to accept a value and close out the program. So that's a problem as well. Next, the program freaks out when we enter something other than an integer. So this could be a float or a character. So let's go ahead and type a and press enter, And you'll notice that the program immediately closes out because it didn't get the correct input type that it was expecting. The second cin was not evaluated correctly. Instead, we're going to use something else. We're going to be using a string. So we'll go up to the top and we'll type include, and then we're going to type string. And this will import the string library so that we can perform string operations. String is pretty much the same as char star with a few little exceptions that we will cover in another tutorial. So here we're going to go ahead and replace char star with string. Let's go ahead and save it. And now when we run it, what happens is we can enter in a series of letters and it'll accept it just fine. Again, ASDF, whatever. It works great. So however, this does not solve the space issue. So if I type ASDF space F, enter, the program still freaks out over that. So how do we get around this problem? Well, this brings me to the function called getline. So we're going to go ahead and comment out these lines of code right here, collapse them so we can enter in mo code. So now we're going to use the function getline, which takes in everything until the enter key is hit. So all spaces, everything will be included in the string. All right, so let's go ahead and create that real quick. We're going to type string y to create an instance of a string. Then we're going to type cout less than, and then double quotes for sandwich type colon space. And then we're going to end it right there. And then we're going to type getline and then pass in cin, which we had just used. And so again, cin is how we access the input stream. So we're going to pass in that, and then we're going to type comma space and then pass in our y variable we just created up above. And then in that line with a semicolon. Next we're going to type cout less than, and then type creating with the space at the end. That's then trapped in double quotes. And then we're going to do less than, type y, and in that line. And then we're going to type enter again. And this time we're going to continue that line. We're not typing indel at the end of it because we want this line to continue. And we're going to type cout greater than, double quotes, space, and then sandwich, period. There, in the quotes, and then type indel. Finally, we're going to end this with cout, double less than sign, double quotes, press enter to exit, ... And then in the quotes, and then end with a semicolon. And after that line, we're going to go ahead and type getline again, passing in cin and y again, and we're going to end it with another semicolon. This is to stop our program from closing out until we actually enter in something. So let's go ahead and save this, test it, and it pops up with this window. It says sandwich type. We're going to type ham, enter, creating ham sandwich, period. And it says press enter to exit, which is what we wanted to output. So we'll just press the enter key, and it's done. The whole program closes out nicely now. It's awesome. So we no longer have to use the debugger to actually execute and see our results. All right, very cool. So let's go ahead and comment out this code before we move on to our next section. So there is actually two ways of calling getline. And this second way is less preferable for me personally than the first way. And the way you use it is by using cin.getline right here. The difference between this and the other version is that we're going to be using a character array, and we'll cover arrays in a bit, but we'll be using character array to pass in that first argument and then the length of the character array as the second argument. You can also declare a third argument where you declare what letter or number or something you want to terminate the getline at. Alright, so there's a slight problem when combining cin and getline, in that cin passes any spaces to the next call of cin. Here's some code which you don't need to necessarily type out. I just want to demo this for you. So here we have a character array of x created, and again we'll cover arrays in the next tutorial. Here we have a cin call that passes the user input into x. Then we have an output that says 1 on 1. Then we have a getline function, and then an output that says 2 to 2. Another input, 3 to 3 being output, and finally just that one last call so that we can see that the program's run correctly. We're going to go ahead and test out this code. So here I have the pop-up box, and we're just going to type AA in here and press enter. And notice what happened. Here we have the cout, which is outputting correctly, but then the get line is being skipped over completely. Instead, we're just jumping to the next call of cin down here. So we can enter bb, and that enters correctly, and now we type cc to end it, and the program closes out correctly. However, it's very odd that this line's getting skipped over completely. So I'm going to go ahead and comment out this code to demo something new. The way you do this is by pressing Control KC at the same time. And the way that we would uncomment this out is Control KU. And you can also access these two hotkeys. On the menu bar, you just click Edit, Advanced, and down here it says Comment Selection or Uncomment Selection right here. And those are what you need to just do block commenting or uncommenting. And let's go ahead and uncomment this next section right here. And we're going to select it all right here and then press Control KU, all three letters at once. We have two character variables, X and Y, created up here. Next, we have max num char, and this is to illustrate what's going on in this function down below more clearly, which I'll get to in just a second. Then we have a variable called stop at, and then after that, we have cn.get. cn.get is to grab an individual letter or character input from the user, and then we're going to store that in X. Notice that we are not using the extraction operator of double greater than sign. Instead, we're using the equal sign to set the value that's retrieved from the function. After that, we have cn.ignore. cn.ignore is useful in ignoring everything up to a certain point. So there's two stopping points for cn.ignore. The first point is the maximum number of characters that the user could input, the max limit that we will be ignoring. So in this case, it will be 100 as declared up above. And you don't have to plug in a variable right here. You can actually plug in the raw numbers like 1, 2, 3 or whatever you want. The second stopping point is the variable that we set stop at. It is an individual character. It could be a new line character, it could be a tab character, it could be a space, or a letter in particular that you don't like. This is where it's going to stop ignoring and then continue gathering C input afterwards as normal. After that, we have cn.get for the next letter following a space. And after that, we call another cnignore to keep going until we hit a new line character. This new line character is the equivalent of the user pressing the enter key or the return key. Finally, we're going to output those two stored variables and then use a getline to stop the program before it closes. All right, so let's go ahead and run it. We're just going to type ASDF space GHJK. Now what it should output is ANG, the first letter of each of these. It ignored everything after here up until it hit the space, then it started passing the next line into the next C input. And finally, we had the string getLine function at the bottom to stop our program from finishing out until we press enter. And there it goes. Beautiful. So how does this solve our previous problem? Let's go ahead and comment this out with Control KC, and we'll go ahead and minimize that and expand the next bunch of code. First, we have our character array as before. Everything is the same. Now, after the first cn, we're typing cn.ignore 100 characters up until we find that new line character. So until that new line character is hit, we're going to ignore everything else that the user is inputting. All right, let's go ahead and save those and run it. So here, I'm just going to type AAA, enter. It works correctly. BBB works correctly. CCC works correctly. Finally, this is our last cn, so we just type DDD. Done. So everything works correctly now. So again, cn.ignore can save you for getting user input by ignoring everything to a certain point. Highly useful for restricting the amount of information that you want. All right, so that's it for input. Now we're moving on to operators. What are operators? Operators are angry old people who answer phones when someone presses 0 on their phone too much. They are people who love to make others sit endlessly on hold and take pride in how much suffering they cause. They are poopy heads. All right, that's a terrible joke. Operators are symbols, punctuations, and other stuffs that perform operations. They manipulate the data in some way. Some operators that we've already used are the equal sign, which is an assignment operator. The double less than sign, which is the insertion operator, which we've used next to cout. There's the double greater than sign, which is the extraction operator, which we use next to cin because we're extracting stuff with cin and inserting stuff with cout. We've also used the double colon, which is the scope operator used for namespaces. Finally, the last operator is the size of function that we used to measure the size in bytes of different data types in the last lesson. I'm not really sure why this last one is an operator, but it is apparently. Alright, there's also some mysterious math operators that I'm going to introduce you to. So we're going to type out some code and it just says cout less than 5 plus 4 with spaces in between, although the spaces aren't really necessary, double greater than sign, end L. Okay? And we're just going to copy and paste this code 4 more times. Alright, there we go. And then we're going to replace this one with a minus sign, the second one with the minus sign, the third one is going to be a multiply symbol or a star, fourth one is going to be a divide symbol, and the fifth one is going to be a percent sign. Now you may be asking me, but what do these symbols mean? They're so mysterious. Minus symbol, times symbol, I don't get it. Alright, so you know exactly what these symbols are. Multiplication, division, subtraction, addition, and the modulo operator. And just as we said before, we're going to go ahead and create a simple string called y, and then we're going to go ahead and create a getline, cin, pass in y, and then end that with a colon, so that we can actually run our code without needing to set a breakpoint and run in debug mode or something. So let's go ahead and click the run button, and now we see the output. So 5 plus 4 is 9, 5 minus 4 is 1, 5 times 4 is 20, 5 divided by 4 is 1, and 5 modulo or remainder 4 is 1. So the only one that stands out as a little bit odd is this division one. And this is because we're passing in 2 integers rather than 2 floats or even a float. And so as a result, C++ does not convert it automatically into floats like it did in Python 3.0 and above. In this, you have to be explicit and type a .0 if you want it to convert to a decimal point or a double or float. So let's go ahead and press Enter key to close out that program, save here, and then rerun it. And now we'll notice for that fourth entry, it'll be a 1.25. It is now converting all of the values in that expression to float or double values as appropriate. Perfect. Type in enter and it closes out. Cool. So these operators work just as they did in Python. Some other operators you may be familiar with are the plus equals, times equals, etc., which are compound assignments. So if we create int x is equal to 5 here, then we can also go x is plus equals to 8, and then we're going to type cout x and L, save, test it, and there we have 13 as our final answer because the plus equals added 8 onto its original value of 5, and it's done. Cool. So the other ones work just as you'd expect with the times equals, divided by equals, subtraction, and modulo. Alright, so let's go ahead and comment out this code. And now I'm going to introduce you to a very cool operator that was missing from Python that I really wish was there. It is the increment and decrement operators. So we're going to go ahead and create an int called wounds, and then below, and we're going to set it to equal to a value of 0. Down below that, we're going to type wounds, and then type plus plus colon. After that, we're going to type plus plus wounds colon. Now, the reason I'm mixing these up is that you can have the increment operator at the beginning or the end of the variable name when you're incrementing it. The difference is the timing in which it happens, which will matter more when we cover loops in a later section. But for now, these two lines evaluate pretty much exactly the same. And then let's go ahead and type cout less than wounds end L. Then after that, I'm going to go wounds minus minus semicolon, and then just copy and paste that wounds output line. And let's go ahead and save all that and test it. So here we have 2 being output because we've incremented twice right here from 0, so that means it's 2. We output that 2, and then we decrement it by 1, so it becomes 1 there. Very cool. We'll press enter to exit out of this, and that's it for the increment and decrement operators. I'm going to go ahead and comment this out. And now for the logical operators. Most of these you've probably seen before in Python. The only difference is that the and or operator at the bottom, one of the last few, is actually the word and or in Python. That's all. So let's go ahead and test out a few of these. We're going to type cout less than exclamation point true and output that. Then we're just going to go ahead and copy this line and paste it a few times. so that way we can easily just replace the middle section. This one's going to be open close parentheses containing 5 is equal to 4. This next one will be containing the same line, but we're going to replace the first equal sign with an exclamation point. Okay. Next, we're going to paste in here with a greater than sign. We're going to go ahead and copy and paste that to test out a less than sign. Actually, I got this mixed up. The first one is a less than sign, second one is a greater than sign. And then we're just going to copy paste both of those and just put an equal sign next to the right side of each of those. And then for this next one, we're going to go ahead and type open close parentheses with true and true, all lowercase in this one. And then we're going to go ahead and copy that and paste it again. And we're going to type vertical bar for the OR operator. And then the second one, second true is actually just going to be false, lowercase. And we can delete these other ones that we didn't use. All right, go ahead and save that out. And let's go ahead and test out this code and examine what each is doing. So this exclamation point right here means not. So when cout it says not true, it is actually false, which is a value of 0. So this first statement is false. Next we have 5 is double equal to 4, which of course is false. So that's 0. And it's saying 5 is not equal to 4, so that's true. So 5 is less than 4, false. 5 is greater than 4, true. 5 is less than or equal to 4, false. 5 is greater than or equal to 4, true. True and true makes the whole statement true. True and true or false makes the whole statement true. So there's simple logic operations. And if you're ever confused about how logic works, you can always look up logic tables to find out how stuff should evaluate. All right. So let's go ahead and press enter to close out the program. So there are a few other operators that we will be covering at a later time when appropriate, and we'll be also covering how to create your own. But for now, that's the end of this section. Thanks so much for watching. Great job keeping up. Definitely take a few minutes to try these final coding challenges shown here and the debug challenges linked below in the description. On GitHub, you are a brilliant programmer, and I'm sure you can do it if you set your mind to it. I will be posting the solutions for all these problems after groups of tutorials, probably around 10 tutorials from now. But I really want you to develop your own solutions and skills. There's often many correct answers. Please leave me a comment below if this helped you at all, and also check out the comments below if you're having problems. Lastly, please do me a huge favor and subscribe to my channel. It would really mean a lot to me. Hit that like button to show some love. Thank you so much for your support and keep the dream alive.